Hey guys, today's screencast will examine sewage treatment. Remember, we talked about the Clean Water Act, which was passed in 1972, and one of the more important provisions in that piece of environmental legislation was to provide monies towards townships and communities and municipalities to develop their own wastewater treatment facility that would purify their waste stream before it was discharged into the environment. So we're going to examine that process and how these facilities actually work. Before doing that, though, let's actually take a look at what raw sewage really is. And I don't think you need to really let your imagination run wild here. It's probably exactly what you think it is, but it may have a few additional components that you didn't necessarily think of. Some of the obvious ones include the solid material. All right, so this includes debris and grit. It includes some unsightly things, condoms, tampons, bags, coarse sand, gravel, and other large objects. Aside from that, then of course we have the sort of the really dirty stuff, the particulate organic matter, right? So this includes fecal material, and that of course to the layman is poop, right? Food waste from garbage disposals, toilet paper, and other material that will settle in still water. Moving on, we also have dissolved organic material, so some of the more finer material that has been dissolved in solution, or other organic material, including bacteria, fine particles of organic material, and urine. And then finally, we can also identify some of the dissolved inorganic materials, some of that stuff that we try to identify because and to eliminate because of its ability to cause cultural eutrophication in our waterways. So this includes the nitrogen and the phosphorus, those inorganic nutrients that can stimulate excessive plant growth at times. So here is Rochester's wastewater treatment facility. This is Van Laer Wastewater Treatment Facility. Pretty amazing in terms of its capacity. It can handle over 135 million gallons per day. So there's a vast network of sewage pipes that are connected to our homes and businesses, and this water delivers our waste stream to the Van Laer Wastewater Treatment Facility, a consolidated and centralized location. And from start to finish, it's pretty mind-boggling to think about the point of entry where the effluent and the material enters Van Laer and the point of discharge, which is out into Lake Ontario. From start to finish, this whole process takes 8 hours. Pretty amazing. So we start off with very contaminated, perhaps discharge or water with lots of infectious disease and all sorts of other contaminants in it, and then hopefully by the end, after 8 hours, this material will then get discharged out into Lake Ontario about 2 miles out. So by looking at this aerial photograph, you can start to see how it's sort of segmented into these distinctive sections, and that speaks to the nature of how this whole wastewater treatment facility actually operates. Wastewater treatment plants typically have 3 steps to their treatment process. The first step is known as primary. This is a physical method of removing large objects and debris and the organic solids from the waste stream. Step 2 is what we call secondary treatment, and this is where we use biological material, aerobic bacteria, to break down and decompose some of that organic material from the waste stream. And a third step, which actually really isn't found in many wastewater treatment facilities, only about 4% across America. Van Laer does not have an advanced or tertiary method, which uses sort of advanced filtration techniques. Because it's so costly, it's not effective to use it on material that has been so diluted and the concentrations aren't very high. So the Clean Water Act actually requires both primary and secondary. It does not require facilities to have advanced or tertiary treatment processes. However, there are loopholes in the Clean Water Act that allow certain communities who have financial hardship to only undergo primary treatment, and then after which it's discharged into the environment. The Van Laer has both primary and secondary, however. So this is a diagram that you can find in your water pollution chapter, and it's an important diagram. I would take a look at it and get to know it because it shows the sequence of events that occur with both primary and secondary treatment. So we're going to tackle these sort of steps one at a time here. So let's start with the primary sewage treatment. Again, primary is a physical process. It's designed to remove debris and grit, the larger objects, the floatable material as well. It does this by screening out the debris, and then any of the remaining debris settles out in what we call these grit chambers, where it sort of follows and mimics the natural processes of a river system, where the river is slowed down and the reduced flows result in a loss of carrying capacity by that stream, and as a result the larger material just settles to the bottom. Some of the finer material and the less dense material hang out at the top, and that material is skimmed off the surface. This includes fats and oils. So this is the bar screen at Van Laer Wastewater Treatment Facility, and it basically looks like a massive sieve. So this screen actually skims across the water, removing the floatables from the surface and any other debris that it catches in its filtration. This is the grit chamber. Again, slow flow conditions result in some of the heavier debris sinking to the bottom. You can see that sort of crank at the bottom, which helps remove that sludge that settles at the bottom. So obviously what we have here is a waste stream that has a lot of solid material. So in the end, all right, we don't have wastewater anymore, maybe that's been purified, but we still have a lot of solid sludge that's left over, and we need to figure out what to do with that. And actually a lot of that is used in the second step of the process, what we call secondary treatment. So primary alone, it does a pretty good job, as you can see here, right? It removes over 60% of the suspended solids. Pretty amazing. It removes 30 to 40% of the organic waste, but it does not remove any of the dissolved material, any of the pesticides or inorganic nutrients like nitrates and phosphates. So that's all still going to be in the water system. So if you discharged it, you run the risk of accelerating cultural eutrophication. So it's important to go further than this. Unfortunately, though, as you can see, over 34 East Coast cities actually stop here after primary treatment. So they only filter it, they only run the bar screen over it, and they only run it through the grit chamber, and then that's it. And then that material gets discharged directly into a lake, into streams, into the ocean. So there's a lot more that can be done, but because of financial hardships, this is where many communities. So luckily for us, we don't stop after primary. Van Laer Wastewater Treatment keeps going, and we have a secondary treatment, which is a biological treatment. This uses biological organisms to break down organic material. So through decomposition and biodegradation, we use aerobic and anaerobic bacteria to decompose these organic materials. There's a variety of different techniques. There are some that we call trickling filters, which has sort of a bed of rocks and gravel, which has a thin film of bacteria, which is applied to it. And then the wastewater runs over the rocks and the gravel like it would in a river system, and the bacteria decompose some of the organic material. Van Laer has something slightly different. It's called an activated sludge digester, where they take some of that initial sludge that's removed from primary treatment and they keep it in anaerobic conditions for a while. So you can imagine you are a bacteria, there's an absence of oxygen, so there's no possible way for you to do your work. And so this is kind of like analogous to if I were to keep you guys, in our classroom for like 2 days without feeding you, And then after that, I brought you to like the best buffet ever. Well, imagine you haven't eaten for 2 days and now you're super hungry, so you just go to town. So they take this this sludge with an inoculation, a culture of certain bacteria, and then they infuse it with oxygen. And once this happens, the feeding frenzy occurs. And so this organic material that gets brought into secondary treatment gets decomposed really quickly through secondary treatment. Following that, there's still a lot of suspended organic material in the water column, so they use a secondary sedimentation tank that allows some of the organisms to settle out of the water. To facilitate that, sometimes they add chemicals like potassium aluminum sulfate, which creates a flock, a jelly-like flock, sort of like what we're doing in our wastewater treatment in class. And this flock allows some of the heavier material to settle to the bottom and the lighter stuff to sift to the top, and which can be skimmed off the surface. So here's a picture of the activated sludge again. So this is the first time oxygen is brought into contact with this aerobic bacteria, and with all the organic material in the water, that bacteria quickly starts to make work of it and decomposes it very quickly. Now, some of the nitrates in here, the inorganic nutrients, are also taken care of, right? Because we know we have some bacteria which can denitrify bacteria, right? Remember the nitrogen cycle. Specialized bacteria actually convert the ammonia and nitrates into nitrogen, molecular nitrogen, in its gaseous form and release it back into the atmosphere. This is the clarifying tank where flocculation also takes place. So all of that, those organisms and all of that material that's been decomposed then goes to the bottom and is taken away as additional sludge. So wow, look at this. So it's really improved in terms of its effectiveness now. So after secondary treatment, we are at 95 to 97% of the suspended solids and oxygen demanding wastes have been removed. So really amazing stuff. 70% of the most toxic metals from industry can be removed from this process as well as it settles out. 70% of the phosphorus is removed and 50% of the nitrogen is removed. So it really reduces the impacts of cultural eutrophication if we discharge this effluent into the surrounding environment. But you can't remove it just right after secondary. In fact, we need to get rid of some of the disease-causing pathogens from the water, right? The fecal-coliform, the disease-causing agents such as Giardia and cholera. All of this needs to be disinfected. And the way they often do that is by chlorinating the water. So this removes the coloration. It kills the disease-carrying bacteria, which will then, of course, improve human health in an area and reduce the amount of infectious disease. However, there is concern that when you add chlorine into the surrounding environment, the chlorine can react with various hydrocarbons in our environment to form chlorinated hydrocarbons, which has been known to cause cancer and increase rates of miscarriage and affect one's nervous system. But many argue that the cost of not disinfecting the water sort of exceed the impacts of these chlorinated hydrocarbons. So as a result, we still do it. There are some more effective alternatives that are perhaps maybe not as effective, but much more costly. Some sewage treatment plants actually utilize ultraviolet light and ozone gas, and these two things can actually kill any of the disease-causing agents in the water as well. Other chemicals are also added at this time, including iron chloride and iron sulfate. So these are sort of ferric chlorides and ferric sulfates, which also attach themselves and bind themselves to phosphorus and break them down and allow them to chemically precipitate out of solution. Like I said, Van Laer does not go any further from secondary in its disinfection techniques. It stops after the secondary treatment, but some treatment facilities keep it going and use advanced sewage treatment. This is what we call tertiary treatment, Again, you can see only treating about 5% of the wastewater in the United States. These include additional chemical and physical processes. Really expensive filtration devices are used with really like high-tech and space-age permeable membranes that reduce additional pollutants, and they can also remove any remaining inorganic nutrients like nitrates and phosphates. So in the end, we're left with a solid waste problem because we have an amazing amount of sludge that remains from the solids in the waste stream. So what do we do with that? And what happens is they take that sludge and they put it in this massive sort of sludge digester, this like big vat that has anaerobic conditions. And in these anaerobic conditions, anaerobic bacteria continue to break it down. Now, a product of anaerobic decomposition and respiration, as we know, is methane. And methane is a flammable gas, and it's actually a greenhouse gas, but it can be actually burned and combusted for power. So many wastewater treatment facilities actually have their own power systems because of the product of anaerobic digestion. They actually combust that methane to spin turbines and then convert that to their electrical needs. So pretty interesting and sort of a renewable resource in a form of energy that is sort of self-sustaining. Now, what do we do with the biosolids after dewatering from the drying bed? Well, depends. It depends on the condition of the sludge itself. For example, ideally, we want to reapply it as fertilizer, right? We want to keep it in the loop. We want to follow the natural biogeochemical cycles and recycle it and apply it to lands and continue to increase productivity and all that stuff. The problem is Rochester's sludge isn't fit for application as a fertilizer. And the reason for that is because of our high levels of industry, and oftentimes our sludge is contaminated with heavy metals and other toxins. So it's not deemed fit for its application on fields. And you can imagine that wouldn't be good, right? That would get into our food supply, into our drinking water, that would run off the land back into our environment. So instead of it being used as a fertilizer here in Rochester, historically it was always incinerated. But that also poses problems. When you burn anything, we run the risk of creating primary and secondary pollution in our atmosphere. So that's a big issue. So we stopped incinerating it, and now actually we bring it to landfills. But of course we know there's only a finite supply of space on planet Earth, so this certainly has a tendency to increase the volume of our waste in these landfills. Landfills are also notorious for leaking, and the leachate, the contaminated water from these landfills, can contaminate our drinking water and groundwater supplies. So that's another consequence of this. If you guys were interested in to know what this actually looks like, this is, in fact, the remains, the dewatered remains of that sludge. And actually, this has sort of a real name to it. We call these sludge cakes. Yeah, I know it's not a cake you want to eat, obviously, here, but this is the dewatered remains that then gets transported from the Van Laer Wastewater Treatment Facility to our nearest landfill. And so that is trucked there. Those trucks can be kind of stinky. So when you see these trucks driving through towns and communities, oftentimes you'll get this smell of strawberry. They use these amazing sort of air fresheners in these trucks that drive by. So when you're smelling strawberry from a truck, remember that might be a mask for what's really happening here. Anyways, that is the process in a nutshell. So stay tuned, and we'll have some more screencasts for you in the future. Thanks, guys.